And data handling instructions. So hopefully when we get done, we'll be able to use PLC instructions to move data from one register to another. That's probably the one instruction or group of instructions that you'll see pretty regularly. I'm going to create stacks for storing and receiving data from PLC memory. That is first in, first out, and last in, first out, known as FIFO and LIFO. Move data between tables, which is basically moving data from one register to another, and then use PLC instructions for number system conversion. So you guys would never get away from numbering systems. Data handling instructions used for reading, storing, retrieving, and writing of data on ports and registers. Anybody remember what a port is? Inputs and outputs, exactly. Very good. Moving or copying data to another register or file, converting data to a different number system, and performing a logical operation on the data. Data handling instructions that you have available to you are move, which the name doesn't exactly explain what it does. The move instruction actually copies data either from a constant value or a data register to a data register. Typically when you move something, you move it from here to there. It's no longer over there, it's now over here, right? When you move data in the PLC, it copies it. So you still have the original over here. Masked move, we did a little bit of that last week. Remember, the masked move uses a bitwise AND instruction. And anything that is masked with a 0 does not go. Anything that is masked with a 1 does go. FIFO load, FIFO unload. That is first in, first out. That's how you put data in the register and take it back out. The first bit that goes in is the first bit that comes out. If you think about things traveling down a conveyor, the first item that comes on the conveyor is going to be the first item that leaves the conveyor on the other end. Right? LIFO, load and unload. LIFO is last in, first out. So think about when you go to the grocery store, you put your stuff in the bag. You put the eggs in the bottom and then the meat and then the bread on the top. When you get home with the grocery, you take the bread out first, then the meat, and then the eggs. Okay, so the first thing that went in is the last thing that's going to come back out. Okay. Copy file. That is used whenever you want to copy the contents of one data file into another, specifically when you are wanting to do integer to floating point to integer, that sort of thing. Yes.
So, the command can't do that?
No. No, move has to be, I probably should have mentioned that, move has to go from integer to integer, floating point to floating point, that sort of thing. File fill, rarely used, but it is used, and we're actually going to use it in the lab today. The file fill will allow you to take some value and fill as many words in a register that you want with the same information. The only time I've ever found that to be useful is when you need to clear out an entire register. You write zeros to everything in it. with a single command. Convert to BCD. Remember what BCD is? Binary coded decimal. So we're going to convert things to BCD, convert things from BCD, convert degrees to radian, or sorry, radians to degrees, and then degrees to radians. Nobody uses radians in the normal world. Anytime you're using radians, it's some kind of a very scientific process. You know, unless you guys go to work for a nuclear facility, you're probably not going to even be remotely worried about it. Index register, sometimes called a pointer. The register that holds an address of a double byte word or file. You know, remember what a byte is? Byte is 8 bits. So a double byte is just a 16-bit word. Why they call it a double byte word, I don't know. It's just a word. Used to move a word into a specific address, and data is placed in another data register. So that R6:0 and whatnot that we used last week in lab, that's an index register. Example of move instruction transfers a number into a register or transfers the content of a register into another register. So the top one there, moving a constant value into N70, and the bottom one is moving contents of N70 into the preset on timer 0. Ladder diagram using index register. S24 is the index register. I've never once seen that done. If you're talking index registers, it's use R6. Mass move hides or masks a portion of the data prior to transferring it into a register. Example using mass move. Read the data from an input module number 2, mask the lower byte of the data prior to transferring it into address B30. So so, you know, that's your inputs that are on. You want to move the lower byte. This is the lower byte. Zero through 7 is the lower byte. 8 through 15 is the upper byte. Okay. And then if you remember, this is a bitwise AND. Anything ANDed with a 0 is a 0. So that's your mask. Moving it into V30, that marker has just got dead. Everything here going to be all zeros because anything masked with a 0 is a 0. Or anything ANDed with a 0 is a 0. And then this one you just copy down whatever is in here. So 0, 1, 0, 0, 1, 0, 1, 0. That'll be the contents of your B30 file. Okay, pretty easy. But module 2, data is ANDed with mask FF00. Set the lower bytes to 0, and the upper byte has the same data as input to module upper byte, which is exactly opposite of what they said in that. Oh, they're masking out. Okay, so it's exactly opposite of that. They're masking out the bottom, the lower byte, and only transferring the upper. Okay, that makes sense. FIFO and LIFO, there you go. Data registers stored and retrieved in 2 different ways. First in, first out, regular conveyor. Last in, first out. It gets accumulated, and then so as things are coming in, they go down into the stack, and then whenever you bring them back out, one comes out first, and that one, and then that one. FIFO and LIFO's concept is storing and retrieving pallets in a similar way. The way data is placed in and retrieved from the stack. Stack in PLC or computer terms is a group of consecutive data registers or words placed temporarily in a memory location or buffer. So you have to start at some point. It's typically 0, and then every word, consecutive word is used. So 1, 2, 3, 4, 5, 6 until you get to however many you want to store. When stacking the data, the stack grows larger as data registers are placed in the stack. Stack grows smaller as data registers are removed from or retrieved from the stack. You remember that? Over here. You push data on the stack and then you pop the data back off the stack. Why it's not push pull is totally beyond me, but I'm not the one who invented it. I'm just the one that has to teach it. And FIFO operation, first item in is first item out. LIFO, last item in is first item out. Push is placing on, pop is retrieving from. Allen Bradley, Slick, and Micrologics for operations. Load, unload, FIFO, and load, unload, LIFO. The lab deals a lot with the FIFO and LIFO. In PLC systems, stacks are created when stacks of integer words are stored into the memory buffer, and that data can be transferred into a register or another memory location from that stack. And for our purposes, we're going to be pushing data onto the stack and then retrieving it and writing it directly to the output data table. So think about the way your PLC scan works. Input scan, reads the status of the inputs, updates the input data table, processes the logic, updates the output data table. Output scan takes what's in the data table and writes it to the physical outputs. Housekeeping. Okay. So we can, I was going to say manually, but it can be automatic. You manipulate the data that's in the output data file, and you can turn inputs and out, or you can turn the outputs on whatever order you want. And you can use a switch or a push button or a limit switch or anything to trigger that next step. FIFO load. That's the answer to, well, close anyway, to one of the lab exercises. The main thing that's wrong with this on that FIFO unload, anybody spot it? That has to be word level addressing. That is the data file type. That is the slot number that doesn't tell you what word that's actually going to write to. Should be .0. That is word level addressing. It must be a period. If you put a slash in there, that's bit level addressing, and it'll go Just like if you don't put the .0 on there, it'll go LIFO, same thing. There again, source. Input 3. Needs to be word level, so input 3, .0. And then on the way out, O:4 needs to be O:4, .0. Copy file and file fill. Data handling instructions are used to store blocks of data in PLC file, copy and file, or copy and fill file. And use these instructions to manually enter a file with constant numbers or data from another file. So if you want to copy from one file to another, the beauty of copy file is you can tell it that you want to copy the first 6 words out of a file, one file to the next, and it'll do it. Okay. With a move instruction, it's 1 word at a time. And then, like I said earlier, the file fills the destination with whatever the input is. Only practical use I've ever found is you want to write all zeros to a file, clear it out, specifically in your FIFO and LIFO instructions. So file fill, number or the content of a register. So it's the same thing over and over and over and over and over again. And then when you copy, this word goes here, this word goes here, this word goes here, and so on. Data conversion instruction used to convert content of a PLC register from one number system to another, or one unit system to another unit system. So you can copy from integer to integer, or go from integer to float and that sort of thing. Data conversion degree converts angle from radians to degrees. Radian instruction converts the value of an angle from degrees to radians. TOD is 2 BCD. It takes your source register and converts it to binary coded decimal or BCD. Places the result in the destination, and from takes BCD number and turns it back into binary and places it in the destination. Oh look, more typos. So taking the contents of input 30 and writing it into output 60. Same thing there.